All right, we're going to do a test here, a capacity test with the cube. We got some conventional, original conveyor belts that came in with the cube. What brought this test on is we had a friend out in the field that basically made a comment, so we're interested to see what the difference is, that he didn't feel the dream mats in the cube could handle large cleanups. So we're going to do a volume test. And what we're going to do is we got this bucket of tungsten grit, 30 to 40 mesh tungsten, we got 10 pounds of it. So we know that tungsten weighs the same as gold. And we got this clean grit. We got the cube, we got it set up. I kind of pre-wetted it, I'll run it, scrub the bubbles out. We'll get this guy set up. We got the 3 conveyor belt trays in it. And we are going to do what we call kind of like a capacity test. How much gold can this hold? So in theory, let's take a look. So what I believe in theory is going to happen. In theory, the conveyor belt is 12 by 12 by 16th inch deep. But that's the whole belt. We know we got about 50% of that is volume that gold can fill out. But total volume is about 9 cubic inches. 1 cubic inch of gold is approximately 316 grams. Times 9 cubic inches would be 2,844 grams, which would be approximately 100 ounces. But we know half of that's mat, the other half isn't. So like if you filled this mat up with water and then dumped it out and measured the volume, you should get probably about 4.5 cubic inches of water. Okay, so anyways, so which would be about 50 ounces of gold that tray could hold. But we'll say, in theory, 100 ounces is that total area. So those 3 trays, in theory, should hold about 300 ounces. Should expect about 50% for mat volume. So about 150 ounces of gold would be as if you packed it completely all full of gold and then just dumped it out. But we know that ain't what happens when you run the material through, that we have losses and it settles in on its own. So we're going to run this grit through there, do a good job going side to side, 10 pounds, let it run, and we're going to see what it can capture. And we'll pull top tray weights, middle tray, bottom tray. Now, just for some geeky math, let's look at the micromat is about the same as the conveyor belt as far as depth of its capacity to hold. So we'll call it the same, 9 cubic inches. That's a theoretical 100 ounce, which you know is only about 50 ounces. But the KD mat is a 1/4 inch deep, not a 16th, it's a 1/4 inch deep. So that's 36 cubic inches. 36 cubic inches is a lot more. That's basically 4 times the amount. Okay, so in the Dream Mat Mini is 12 by 12 by 3/8, which is 54 cubic inches. Now we get this really geeky math going. We'll go to this side. That we're going to be about 100, same as the cube on the micro, but 400, which would be the 36 cubic inches, is 11,375 grams. It's about 401 ounces. The mini is 17,063, and that's about 602 ounces. So that shows you kind of how much more volume that these mats hold compared to the regular conveyor belt. But we should see expect about 50%. So what we're saying is that the Dream Mat system should hold basically about 550 ounces of gold. But we know when it runs, it's at an angle and it cleans out. So this is just geeky math, but it's trying to show people, help them understand that the volume in these mats is 4 times on the KD. More, which is 6 times on the mini. So actually its ability to capture and hold volume is a lot larger. So, okay, the geekiness, we just got some little facts there. Now we'll get this thing up and going, and we'll take this grit, I'll show it to you, and we'll run this through here, and then we'll just look at what real world says. Nothing else in it. I could do a black sands test later because someone's going to say, well, it ain't the same with black sands. But basically, we're given every opportunity for this mat with no competition to grab gold material, 30 to 40 mesh, gold basically material, which is this tungsten grit, and fill itself up when it's doing this. So it has 100% of the opportunity to see what it can do for basically capture. So we're going to see what this system can capture in volume. Then of course we'll weigh it, and then we're going to turn around, put the dream mats in it, and we're going to do that. So we're kind of help people understand one of the things that we focused on, and one of the things we looked at in the design was how the conveyor belt is flat, and it doesn't even have like a terrace step, you know, like stair steps. And it isn't progressively falling back, where basically its ability to fill up and slick out, it has that ability just to slick out. And what we wanted to do is we wanted to get profiles that were set up higher, that terraced, and still had good exchange that allowed for material to hold and then work itself upstream, which DreamMat does. You know that the cells do not have the ability in the conveyor belt to move material back upstream. And all of the cells in the DreamMat patterns have the ability to take material and move it back upstream. So anyways, besides that, we wanted to focus on being able to process more material faster at a higher flow rate and push more volume, but also have the ability to capture more volume. So that was our goal. And so we're going to see what the difference is, and we'll do this test, and we'll just let math do its thing, because it should be kind of a similar correlation in the field in its ability to capture gold. All right, let's run a test. All right, here's the 3040 grit tungsten, 10 pounds. Let's take a look at this stuff here. This is what we're looking at for grit. So we got 3040 grain for mesh. So that's what we're going to be running, the size of the material that's going to go through there. So it's going to be a good test for fine gold recovery, because it has the ability to float out and not get captured because it's flat. It's not a round grit. It is, I guess if we were to look really close at it, it's kind of like almost somewhat triangular shaped, you know. All right, tungsten chips, a little grit. Okay. We're going to scrub the bubbles out of the mat, so that it gives it every opportunity to fall in. And we're going to do that on the hyperlapse, so don't spend so much time on the video. Alright, here we go. We got our tungsten grit. Woohoo! Look at that stuff. We're going to go across the top of that tray. We're going to run 10 pounds. I wish it was gold. I wish I had 10 pounds of gold. I don't got 10 pounds of gold. I guess I'm not a real gold miner, because I don't got 10 pounds of gold laying around the same grit to run through the cube. A little humor there. But anyways, so we'll use the next best thing. Here we are. We're running that across the slick plate. We're going to do this nice, because we don't want to do the overload thing. We're going to let it spread and slide off of there. We're just going to build it up on the slick plate. We can get piles on the slick plate. Cool beans, so that'll give it a chance to go through the G-force little separator seal that allows it to stir up and not like get plugged up down there. Give it a chance to run that out. All right, we'll put this on a hyperlapse, not to eat up so much time. All right, there we are. We ran all our grit. She's empty. There it is. You can see that mat is just full of that gray tungsten grit, just full, but you can see the top of the mat. And do we have material out here? We actually do got material. We'll turn it off here. And we'll see what she says. And this is what we see, the pile of grit below it that it spit out. So we're going to see how much each mat caught. And it filled up really good. I did a good job of going back and forth, sprinkling it evenly. I wanted to really make sure I didn't blob anything in the center and have, you know, like the ability for it to have to deal with a big blob. Kind of sprinkled it on like a pepper shaker, but it looks like we filled these mats evenly. I'm gonna go ahead and put the camera back up here. And I'm a little bit closer with my super dolly Hollywood camera setup. All right, take this out of the quick release. This is the slick tray, nothing on the slick tray. There's our gold, or our tungsten. So it looks like we got a pile that built up here. I expected almost a pile all the way through, but we filled the mat good, and we caught here. So we're just gonna leave it like it is. We're not gonna take that out and not count that. We're just going to count everything. So here it is. Here's our total, our mat coverage. And you can see we're just filled completely. But we can still see the top all the way through this. So let's go to the second tray. And we have less here. Just a little sprinkles in here. Nice buildup on top. And the mat is completely full again. Got a couple spots. Have little holes. All right, that's the third tray. Ugh. Sprinkles in there again. Maybe this is in the way, I don't know. And it's filled up pretty good. All right, so that we did a good job of completely covering the mat. All right, so now let's go ahead and put each one of these in a tub and rinse them out, and then we will weigh. We'll do a wet weight, and so wet weight against wet weight. We'll just get most of the water out, and we'll do basically see what each of these trays caught and what this capacity is. Cool beans. Just want to get the entire cleanup process on video. So we got the top tray that had the slug of stuff in it. So we're going to go ahead and rinse this out. Don't want to get the scale wet. Let's just go ahead and move the scale out. Just a little bit. All right, looking good. We'll pull the tray up to the camera before we call it good. It's pretty nice and liberated. No ways really for this to get caught in there. So as you can see, we got this nice clean black tray. Awesome. All right, top tray. The tungsten in there. Dump the water back out there. We're going to put it in the tray. I zeroed the scale on the pan when it was empty. See if I can do this without spilling it. Well, so much for not spilling it. Leave a little bit of water in there so that we can get the tungsten down. Pretty heavy stuff. Looks and acts like gold to me. It is pretty cool. They use this industrial grit for making like those sander wheels, stuff like that. They put it on there, sprays it onto the metal, and that allows them to make those grinding wheels and stuff like that. So figured it'd be good testing material. It'll come in handy one day. It sure did. Been kind of wanting to do a test like this. Pretty empty. Here's our drain off of the material. We're not going to spend all day drying this out. We're just going to drain off the water without spilling the grit. We're floating a couple little grits out of there. We're not too worried about a couple little grits dropping. This is just a good estimate. This isn't nanoscience. Here we go. Waiting a little bit for the water to come down through the material. All right, there it is. There's our cube capture. Let me look at my camera. All right, we can see what's going on there. There's top tray. All right, we got the scale sitting over here ready to go. And scale says 2 pounds, 7.1 ounces. I'm going to write that down with my little magic marker that I set somewhere. And I see it right here. Top tray. 2 pounds, 7.1 ounces. Cool. All right. Now we need to switch this. We could actually just switch this into the tub because we don't care what we've lost in the tub and what that amount is. We're looking at what has been captured. So we're going to see who can capture the most material, who holds the most material, who migrates the most, loses, or not loses, has less recovery, and who captures the most has the most recovery. So I'll have the same amount of known material, 10 pounds. All right, so let's go ahead and switch this down in here. Get it off into no-go land. Pan's empty. Now we need to do the scooperoo. Sorry for the super long video now that you gotta wait for me to do this stuff. We'll do tray number 2. See how she did. There should be less because it didn't have that slug of material in the G4 separator. And neither did the third tray. So the second and third tray looks like they should probably be pretty close to the same. So here's the second tray. You can see that slug of material, like I said, wasn't in it. There's some material in there, but not like the top tray. Get this guy rinsed out. All right. Looking good. Here we got a nice black tray. No tungsten in it. It's nice and clean. I don't see no tungsten grit hanging out anywhere. Woohoo! All right. Third tray. Second tray. Here's our material. Here's our pan. Here's our tub. Let's see if I can get it in there without spilling it this time. Come on, second try. Better. I'm learning. See, look at that. See? My wife will be proud. I learned something. I did less of a mess the second time. Our wives are always proud when we learn. Us men, oh, I got all the, darn it, didn't switch all the material down. Well, I sort of learned. Halfway learned. Okay, anyways. Good try, faked it. All right. Let's get our material to the bottom corner. Some people say, some people that aren't real savvy with different materials, and, you know, or geologists or engineers, and they're wondering why we're using tungsten, and tungsten and gold are basically the exact same weight, as far as we can tell. Now, on the atomic scale, there's a little difference, but not much. But tungsten is really brittle and hard, and it is not soft like gold, so it doesn't have the properties gold does that makes gold valuable and tungsten not as valuable. But industrial-wise, it has lots of value because it's so hard it can kind of cut through everything else. It's just harder than other metals. So, and that's why if they machine it and they break it off with these little chips, and then they screen off in different sheaves or different screens. Just trying to get that tungsten grit not to be floating. That's how small this is. This tungsten grit is even floating just like gold because it's flat and got high surface tension. So this is a really good test. This isn't like BBs that would slip through and not have high surface tension, would have low surface tension and sink through the material real easy. So this is a really good test as far as the correlation to not being dust, but being gold-like material. Only difference is this is not soft, it's hard metal. All right, here we go. So now we got this other tray of gold, second tray, or tungsten, and we are going to measure out at 1 pound, 13 ounces, 13.4 ounces. 1 pound, 13.4 ounces. Got to write that down. £1 pound, 13.4 ounces. All right, written down. Cool. All right, one more tray. Thanks for bearing with me in this hodgepodge of doing stuff here. Woo-hoo. Get out in the water. Goodbye. Something right there. Acts like gold, wants to stick, that's good. We want those characteristics. Now we got a super duper. Fill up the tub for the last tray here. So there was quite a bit of a slug in that, as far as weight goes, in that top tray to get that amount up like the bottoms, because theoretically, if your recovery is perfect, each tray should have the same amount of gold in it. It shouldn't see, you don't want to see migration or losses. So hopefully, what we'll see confirming that, and we'll get a good confirmation, is this will weigh closer to the second tray because it doesn't have that slug, and that will give a good confirmation that we distributed the material in there evenly. All right. So we got this tray that's nice and clean. No tungsten. Good news. All right. So those were Go Cube trays with the original conveyor belts that came with it. All right. So we're dumping out water. All right. Third time to get really good at this. Look at that. Oh, jeez. And I botched it. I'm smarter. Remember to keep the water in there to get my grip down. Man, I'm not getting good at this. Actually, I do this for a living. Teasing. All right. Water in the pan. Get way up there. Yeah, acting like gold. That's good. All right. Drain that water off. Woo! Did you see that? It was all in out. Kaplunk. That just like would have been awesome. I'll have to do the test over again. All right, here's our pan. Tungsten for the third and bottom tray. What's the scale gonna say? 1 pound, 14.8 ounces. 1 pound, 14.8 ounces. So we are a little heavier. 1 pound, 14.8. The other one was 13.4, so we're a little heavier on the last tray. So, but really close. So that was a good that was a good confirmation for us doing the test that we did a good job covering the mats with the tungsten in the material. That we didn't have no weirdo type number flashing out on us. All right, so now we're just gonna drain that tub, fill it, get the gold cube set up with the dream mats in them. And we're gonna do it again, guys. All right, let's go. All right, I want to kind of show you guys that this grit went into the tubes, the pickup tubes to the other side, went out on the other side, and actually we have grit coming out the other side. So this is acting like gold floating through here. There's 30, 40 mesh flat material. We are seeing those characteristics. This isn't like some really dumb ball bearing test. This is a good test. All right, here we are set up. We got the micro, we got the KT, we got the mini set up in the cube. We got our tungsten in the bucket. Not the brush, we don't need that. We don't have to worry about bubbles. All right, so we're gonna go ahead and turn this baby on, do a time lapse, and we are going to feed this material through there. All that tungsten, and there's some dog hair in there too, which is really cool. Anyways, and go from there. Sweet. All right. It's our empty bucket. Being wet, the material fed a lot faster. I probably, not twice as fast, but it was a lot faster feed because it clumped and it came off in bigger chunks, so I went through the bucket a lot quicker. You actually do a time the feeds in the hyperlapse and actually do the math, and you can figure out how much faster it was. So anyways, so we got, come on, I'll go ahead and put this back in the camera stand, and we'll hold up the trays and take a look at them. All right. Top tray, dream mat. Got a big slug just like the other one in the same spot, which is good. So I was worried I was going to get a little cheated on that, but no, don't worry about it. There's the material in it. All right. You can see the material in the second tray built up. Ooh. And then we got the material in the last tray. There we go. All right, well, let's do our pans. We're gonna clean up tubs and get that set up and go to town. All right, do I have the pan in that shot? I sure do. All right. Let's see what we got. Scale. second mat. Looking pretty clean. Sweet deal. All right. Let's get her into a pan, get a weight. Practice some more spilling. Okay. Get that tungsten down there in the corner. All right. All right. Micromat, top tray. There it is. Let's get a wet weight on that scale. 1 pound, 1.7 ounces. Write that down. 1 pound, 1.7 ounces. All right. All right. I need that water for a second. Tray. Cape D mat. I use this specifically. I consider it a black sands mat, beach mat. Don't really want to run gravel or that kind of material through it. So it's really designed for us to help people maximize the amount of mini hydrocyclone cells in the mat for sand-sized particles. So it's kind of a mini. Yeah, so. There she is, all clean. Cape D. Let's see what it says for weight in the pan. Pretty good. Looks like that volume math was pretty good. I think we're a little shy on the volume math on the micro, being it is actually a little bit flatter of a pattern than the conveyor belt. Just mean it's got more flat facing surface area to get that hydrocyclone action going. Does a good job, good indicator mat. And I've always told everybody the micro mat's not a primary recovery mat. I consider it a good indicator mat, and it does a really good job. And it can be worked slowed down with for final cleans. Train's empty. And a lot of people like the micro. It really cuts down on their cons, and they run it a lot slower than what we just did for cleanups rather than primary recovery. There's our tray for the Cape D. All right, what's the scale gonna say? 4.52 pounds. 4 pounds, 5.2 ounces. Write her down. Right. I like that number. Works for me. We could stop there, but you know, we want to know. We want to know. We want to know how much the mini mat got, which is the first and original cube mat tray or mat I designed to increase capture amount and increase feed rates and increase size of material you can run through it. I believe you can shove 3/8 through the cube and turn up the volume very easily. Turn your cube into a mini high banker. Is my opinion. And that's what we did. Using science, using a different mat design, newer, more advanced mat design. We think that we can increase the performance. All right, let's see what the tail tells. We have the mini. Let's see what the beast tells us. Mini, cleaned out. All right. Here's should be the boomer. The big kahuna. The I Ching. The persona. The who's your daddy? Come on. The what's in your box? We got all sorts of fun sayings. We do our best to hopefully enhance and create a better processing environment for everybody that buys our product. We appreciate it. We also uber appreciate Gold Cube and letting us distribute for them and put our mats in their box. It's awesome. We appreciate it. It is awesome. It's some great recognition for the hard work that we've done and the great product they have. All right. Get the dog hair out of there. I know that dog hair weighs a lot. They really set off the results to that dog hair. If you listen really closely, you can hear them over there chewing on their squeaky toys. I think they killed the squeaker, actually. There it is. There it is. Yeah. All right. Mini mat. Material in the pan. It's full all the way up around the edges. All right, let's take a look at what we got here. For weight, we got 5 pounds, 8.6 ounces. 5 pounds, 8.6 ounces. All right. There it is, folks. Now let's take a look at our board. We had the top tray of the cube, traditional conveyor. The second tray below it. And the third tray. We had a big glob of material in there that helped out with that, or else it probably would have averaged out right in that 1-point-something ounces. We had a glob. Our mat's a little flatter on the micro. But then we had a big increase of volume on the Cape D. And then we had a larger increase on the Mini, like I predicted. So 5 pounds. We might have to do this, take a break, and I'm going to get my calculator out and do the math and see how close we are to 50% on our goal here and 50% on our goal here. We'll just take a quick math break and I can figure it out. All right, here's our numbers. So we got 6 pounds, 3 ounces in the 3 trays of the cube with the conventional conveyor belt, and we got 10 pounds, 15 ounces in the Dream Mat. Now hold on. You know, like my brother even asked, how did we get more than 10 pounds? Well, we got some water weight. So we got to consider that we did wet weights. And so that's the reality. And we still saw some come out, of course, not as much, in the tailing pile. So we still had a little bit in the tailing pile. So the water weight's adding quite a bit. So, but wet weight, if you were to tally up and break those down to ounces, we got 175 ounces and a half out of the Dream Mats. And we got 99 ounces out of the cubes. So that's the conversion. All right, you guys can check my math. But besides, all the predicted what it could take on, that we basically predicted 150 ounces total yield out of the cube, and we got 99. We predicted a lot more volume out of 550 out of the Dream Mat, but we only got 175 because, of course, it's a terrace, like a stair step, in meaning that you're stepping down like this, so your material's filling up like that, and I'm dishing out a little bit. So your material kind of is filling up in each one of these cells like this, so it's not that true 3/8 volume got full because of the way it was at an angle. So you gotta imagine if you had the tray at an angle tipped, and then the water would drain out, so you would lose a lot of it. So that's basically makes sense, that the total volume height of the mat is at an angle, and you can't really measure it flat and guess the volume out of it. So there should have even been more of a deduction for that. The cube mat, which is conveyor belt, is pretty level, so it's even at an angle, it will hold a little bit more of its water. So you kind of can see that. So it makes sense. So through some deductive reasoning, you can kind of see where the numbers land. But total capture, wet weight, we caught almost 10 pounds of wet weight. Over here, we caught 6 pounds of wet weight. So we see a 4-pound spread in between the two devices. So can it handle, a larger cleanup? Well, it looks like it can handle about 4 more pounds of material. That's, for gold, that's like silly, make your head soft numbers. Doesn't even make sense. Well, we appreciate you guys hanging out with us, doing this test, having fun, and just keeping it light. And our testing, of course, is just for our own curiosity. I'm not going to put any claims out there, except for you buy one of these, you don't absolutely love it, we'll give you your money back. That's just the way it is, because we want all our customers to be absolutely satisfied. And we're waiting for one to come back. Hasn't happened yet. We challenge you to pick one up. We hope we can make you happy. We'll even put a smiley face on the invoice in the box. But, you know, at the end of the day, we just want to catch more gold. So hopefully this test will help you see that we kind of caught some more heavy metal. All right, guys, have a good one. All right, one thing I didn't do is get the total wet weight of all the grit. I didn't even weigh the bag to see if it was a true 10 pounds. They could have threw in more. But we want to see the total weight just because of all the grit. Because we want to know. Inquiring minds want to know. We want to see the total weight so we'll know what we lost, what we caught. Right. Tub. Ooh, full pan. Probably got about a pound of dog hair in there, I'm pretty sure. We'll have to go, ooh, don't let it fall out, Dave. Wet weight, total wet weight. 12 pounds, 5.9 ounces. 12 pounds, 5.9 ounces. Total wet weight of grit. So I imagine if we take the water out of it, I doubt there's 2 pounds of water in there, so they gave us a little bit more in that little keg of material. I don't know exactly